Alright folks, in this brief video I want to talk about a notion of cost. So we looked at some sample edits, I have them up here on the screen again, and I made some argument about how I thought the edit from DNA source, DNA target 3, was minimal when we talked about just moving G. It was more expensive to talk about substituting C for G, and then A for C, and then T for A, and then G for T. Why is that? Well, my intuition here is if you just delete a G and then put a new one in at the end, that's two changes, right? If you think about it as keyboard strokes, I'm not going to count arrow keys for like navigating the text. I'm just going to count the times that you type or delete. Okay, so at that rate, it's two moves. It's a delete and then an insert. Whereas if we did four substitutes, that's either delete, insert, delete, insert, delete, insert, delete, insert, or if substitute is its own command, right, like you use shift and an arrow key to select and then overwrite using our modern keyboards as an intuition, then okay, then it's still four. So roughly, I want to use number of edits to characterize the cost. We can make this formal by defining a function that identifies each edit that we write with some amount of cost. Right? What's the cost of an edit? So to formalize this idea of like, look, typing on the keys, like letter keys, that costs. But just navigating with the arrows to move around, that's going to be free. Right? That's going to be the general model that we take. How might we turn that into a function? Well, here's a function cost that implements that idea. You give me an edit, I'll give you a natural number that tells you how much it costs. Now here it's sort of like golf or shopping, right? Like lower is better, right? We want low cost edits. That sort of like indicates that things are closer. So long-term goal, we're going to want to find we're going to develop an algorithm, but we're going to want to find um, the lowest cost edit, the minimal edit between two strings. So here's the cost function. Let's look at it. We say the cost of copying is 0. So this is the case. So like if you go back up, so copying here is sort of what happened in the delete G, add G at the end model. I copied C, A, and T from strand 1 to strand 2 is sort of the intuition for what's going on here. So we're saying that that bit's free. Maybe a better way to say copy would be to say leave alone. Like just leave it there. Like I want to keep it. Don't mess with it. So that we're going to call free. That's like skipping over a letter with an arrow key. Every other edit costs exactly 1. And I want to approach the nuance of this a little bit more. So deleting a strand, that's pushing the backspace key or the delete key. That's going to cost us 1 edit. Adding a base, that's going to cost us 1. And now this underscore says, look, it costs the same to add a G or a C or an A or a T. I don't know if this is biologically true. I would guess that it is. Like, I don't know. But let's just suppose that it is. But in the algorithm, this is the way that we do it. We assume that the content doesn't matter. Now, lastly, we established earlier that, like, well, there's two ways to think about substitution. A substitution could be delete a letter and then add right away. Right? That's a substitute. You delete it to get rid of it, then you add right away. Or vice versa. You could add and then delete the thing from the. That would be a cost of 2 because you'd have 2 edits, right? You'd have to do 2 things. But we're going to say substitution is 1. So, like, why? Why do we say that? Well, it's some belief about what could happen. So, if what you're thinking about is, say, somebody typing at a keyboard, adding in an extra letter or omitting a letter is sort of the cost of 1 keystroke difference. Substituting a letter, it's the same number of keystrokes, but you've made the wrong one. So it's like not as bad as sort of 2, right? It's not like it's going to take us the full delete and then add it in. We'll just say it's 1. If that sort of intuition doesn't make sense to you, that's fine. Simply take this as fact, right? Like, this is the convention. We're going to say that substitution is cheaper than adding and deleting directly, right? If you're not happy about that, I'm sorry. It's the one we're going to do because it's what Levenstein did. And you'll see that it actually works out nicely. It turns out that this is also a really good model, at least for spelling. I don't know how well it does for biology. I assume it does pretty well. And this is just the one we'll do. You could talk about this whole algorithm with no notion of substitution, only with deletes and adds. This whole algorithm, we'd be able to adapt very easily to that setting. So great. That's where we're at. So this function defines the cost of a single edit. And then this defines the total cost of a a list of edits. So let's play around a bit. It'll be a list of edits. So let's see if we can come up with a list of edits that we would need to get from DNA source to DNA target 3. This will be a real exercise later, but we might as well do it now just to look at the costs. Well, to go from DNA source to DNA target 3, we need to delete the G. You'll notice no base comes here. We just say delete it. Then we need to copy C and A and T. Copy, copy, copy. And then we need to insert a G. We need to add a G. What cost is this going to have? Think about it. 2. Why? There's 2 non-copy edits. These functions are not so complicated, right? Total cost is really just summing, mapping cost over the list, right? We could have defined our function that way. I've defined it this way because it's a little easier to work with later. Okay, so much for cost. In the next video, we'll define a function that actually applies edits to a strand to produce a new one, and then we'll be able to see, like, hey, did we get it right? Is this how these edits are supposed to work? What are the costs of these edits? And so on. Okay, so that'll be how we start giving meaning to our edits, right? We gave an intuition for what we want these to mean, but we haven't yet defined it. And that's the subject matter for the next video. See you there in a minute.